What's a day in the life of Mark Papermaster?
Well, I've got a great job because, again, I love technology and my job's twofold. So as a CTO, Chief Technology Officer, I really have to be staying on top of where the industry's going, really listening to customers, understanding the trends, and making sure that that our strategy addresses those needs. So it's about the strategy, the roadmap, really helping bring us together internally in the company to have the right focus on technology. So that's one, and then I also have a dual job of running a piece of our engineering, which delivers our microprocessors and our core technology across the company. So it's a great combination that allows me to do what I love best and work with engineers and help get great products out and work with customers. And I've got a knack for listening. So like I said, it's a lot of fun. It is such a challenging time across the world. For us at AMD, we were fortunate in that we are a global company. So our teams are spread out across North America, India, and across Asia, Europe. And so we had actually already developed, part of our culture was to communicate across the sites, really use the medium we're on today, audiovisual conferencing. So that was already built in. But it very much was an in the office and in the lab environment. I mean, we're a tech company. And so we are fabless. We don't have the semiconductor manufacturing line, but we have many engineers that are in the lab, testing our products and getting them ready for market. So we've kept that going on a central basis. Of course, our facilities team did a great job ensuring we had all the right distancing and safety measures in place. But for the rest of the company, across many of our geographies, it was almost an abrupt shift to work from home. And so what we found is, yes, we were used to video conferencing, but not from home.
Right.
So
Yeah.
it was our IT team did a great job and beefed up the ability to handle the load on the system. We had fortuitously made some investments to make sure we had the right network bandwidth and processing capability. So we were pretty good there. And when the team reacted, so the biggest thing, Drew, was just getting the mindset of the team of just all of us learning, and frankly that the team was so resilient. We really didn't lose a beat in terms of our R&D and research and development, of course, and developing our products. Really proud of the team, but it is hard and it's a different environment. It's a bit exhausting actually when you find yourself, in this kind of mode, just sort of on camera, because suddenly we're all on camera all day.
Yeah, no, we all know the feeling.
You asked my suggestion. The one suggestion is over communicate. I mean, just you used to rely on running into someone in a hallway and things like that. So my suggestion is, and what we've tried to do is just always be proactive. Just reach out, give someone a call, a video call like this. I think that's essential. Over communicate.
That's great. And I want to go one layer deeper on this question. And I did see a question just come in that's sort of related to what I was going to ask. The question that someone just had out there was, what tools are your engineers using as sort of their remote? But my related, I was going to ask you more along the product innovation side of things, to keep, you guys have to continue to innovate. You're a hyper-competitive market. You're always innovating, and product innovation is central to the company.
Yes.
Have you done anything different in regards to product innovation, whether it's using software tools or programs in terms of, or are you kind of using the same, types of tools and programs that you did to track product innovation and hit your milestones? And or is there something different you've added to the mix since we've kind of gone remote? And that could be related also to tools that your engineers may be using specifically as they've gone remote. You can answer either or both.
Sure. I'll try and mix an answer to both as I go through this. So first of all, we have a culture of metrics. I mean, innovation doesn't just happen. New products don't just pop out. It turns out you have to manage them pretty maniacally. And so we have, very much a metric and milestone-driven innovation development process. And it does start in that ideation stage, that innovation stage of what's the problem? What problem are we trying to solve? How could we solve it? and let's pick the three best and kind of run down the road a little bit with each of them, and then pick one and take that to market. So that whole ideation stage it's not as effective. I mean, it's great. What we used to do is fly everyone to one spot and run that as sort of like this brainstorm. And look, when we're past this crisis, we'll go back to that, because there is no substitute for that bonding and that in-person teaming, and just seeing that motion even more more detailed from the person you're chatting with, or the people you're chatting with. But we did take it to the format like you and I are on today. So small groups, we would run that, and it's really proven pretty effective. I mean, including like a digital whiteboard. All of our tools are in the cloud now. And so if you're creating a presentation, it's on the cloud. I could be typing something right now on my ideas. You would see every letter as I type it. I can draw as a drawing. You're going to see it. You see it done. And even in our lab, we did remote instrumentation on our tools. So a small group would go in the lab, but with the remote instrumentation, you can log in. It's called telnetting into the Linux box there, and still be able to control and run experiments in the lab, although you're sitting at your setup at home. So it is in fact the interactions of old, but new in different ways. Well, it's very interesting. Again, as I said, I started in this industry over 35 years ago, and believe it or not, the engines, the chips are more important now than they ever were. And I never would have imagined that they would have only grown in importance over that period of time. But the reason is, and you alluded to it, is the demand for higher and higher performance. What's happened is programmers have really moved the state of the art of algorithms, of what it can do. So, the world is in this transition right now where there's these IoT devices implanted all around us. We have smart homes, smart offices, smart factory floor. And so we're getting all of this data. And how do you make that data useful? You need to process it. You have to compute, and you have to make it useful. And then the algorithms, in fact, have to be smarter. They need to be really taking many factors into account. Well, this is Drew, and Drew is in the communications industry, and what data might he want, and how do I make it useful for Drew? And so there's a lot more processing that's needed to make all this data useful. And around 2012, a set of researchers took an algorithm called the gradient descent algorithm that had been used for years, trying to push optimizations forward, and applied it to in a approach of machine learning that allowed a much higher accuracy of object recognition and voice recognition and processing of data. And so that is also spurring a rapid demand for high performance computing. The Microsoft Turing model, it's just got, it's just shown it has these massive models sizes can get incredible accuracy. Right. And so all of this is driving a demand for higher and more performance. We need it in our own home. We're gaming at home. We want more visual acuity. We want it to be more lifelike. It used to be 1 PC per household, but with work from home, we're seeing two or three PCs per household. So all of these things have just hit such an inflection point where we need more processing for analyzing the data, make it useful, make it smart and intelligent, and visually appealing to us, whether it be for entertainment like gaming or just visualizing the data for my work.
And what has, more broadly, again, sort of the macro view, what has the rise of mobile, right, and just smartphones and all the, I've got 10 applications running at the same time in the era of sort of open APIs and things like that. I mean, has that really driven this sort of, need for performance but talk to me about sort of the impact of this new, just, sort of mobile world on how you guys see, the competitive landscape, and then where you need to go to continue to compete.
Well, what does a mobile world mean? It means that all of us need to be able to get at what we need wherever we are. That's what a mobile world is. So we are connected with a smartphone and typically a PC or a tablet device everywhere we go. And what that does is it means that to get it, that, think about it, you used to have to take go back forever. It was, stacks of floppy disks. Then you didn't even have mobile computing, but
Right.
then it was your flash drives, a little USB drive, or you'd need that data, or you'd store it on your PC or on your phone. Well, you don't think that way anymore. Why? Because we're all accessing the cloud wherever we go. And so mobile computing has changed to where you can work anywhere. You take your mobile device with you, but you can access a vast array of computing from the cloud wherever you go. That had immense impact for our strategy at AMD. So if you go back, 7, 8, 9 years ago, almost all of our business was PCs. Right. And we set the strategy that driving AMD to turn around its fortunes and to drive to be the leader in high performance, because we saw this trend coming. We saw artificial intelligence. We saw the move to the cloud, and so now we do serve the most demanding server processors to the cloud. We're in all the major cloud vendors that are out there worldwide. We are in the edge of the computers, what's called the edge of the cloud. So you think about, when you get information on your phone, it started in the cloud, but then it went to a cell tower and it had processing underneath. And it's 4G today, but it's rapidly moving to a 5G, very fat pipeline to get you information wherever you are mobily. And so we drove high performance all the way from supercomputers that we've just recently won a bid for the most powerful supercomputers from the U.S. Department of Energy, to the cloud, to the edge, to the PC and the mobile device that's going with you everywhere. So it's this trend has, we've reacted to it fundamentally in the strategy we set out at AMD to be a leading provider of highest performance CPU, which is the general processor, and GPU, which is used in gaming and graphics compute. Yeah, Moore's law was a paradigm that was set out really at the beginning of the semiconductor industry as we know it by Gordon Moore, and it said that the transistor density of what you could put on a chip would double about every 18 to 24 months, and we've largely held to that doubling. So in the traditional definition of Moore's law, it's actually still running strong, still true, still running strong. But Drew, it's not the same, because the way it was for many, many years is you were on that Moore's law doubling of transistors, but the cost of the transistor itself would stay the same, or actually go down significantly, generation to generation, and the frequency, how fast you were running those transistors, would go up generation after generation. That's what's not the same. And so we're just not getting the speed bumps we used to. So you are able to pack more transistors in, but the cost of those transistors is going up, and we're not getting that frequency speed boost we used to. So it drives a whole different kind of innovation. As suppliers of these engines to the industry, we have no choice. We have to stay on that old traditional pace that we've been on for years of getting end users more performance at the pace they had been used to. So yeah, it drives a whole different ways to think about what Moore's law is today. Well, luckily, Lisa Su, the CEO of AMD, and myself go way back. We worked together early in the industry, so we had a very, very close partnership, and we had to make a lot of tough calls. So, in any transformation, it's tougher and tougher before it gets better and better. We actually had to cut research and development budgets. And so you can say, well, my goodness, that's a terrible environment to drive high performance and to drive this kind of innovation. But exactly the converse is true. We faced a crisis. Everyone in the company, we knew that we were in a crisis. If we just continued to do what we had been doing, it was not a good future. And so there was a sense of urgency, and what we aligned on is to protect the spend and grow the spend around the base engines, the CPU and the GPU, and and plot out a future of how we could intercept where the market was going, high performance, which is exactly what happened starting in 2017 with the launch of our new family of CPUs, the Zen processor.
Yeah.
And we've just like clockwork been coming out with new generations. We have a third generation of that Zen processor shipping into this year, and each one brings a significant jump in performance and performance efficiency.
In regards to those early days, it's a great product innovation story, and right now we're all companies are going through this sort of acceleration of digital transformation, largely maybe driven by COVID, but digital transformation was happening, and now it's accelerating. You guys faced a similar situation back then, where survival, being able to compete, so you had to accelerate, I would think, sort of how did you manage that process, both sort of the early R&D phase moving to high performance, and then as you really started to develop the product? There's anything different you did in terms of managing that innovation process where sort of speed was really critical? Like you really had to get moving.
Well, speed for sure is critical, but first and foremost, Drew, is actually culture. We had to have and we were very open about this as a team in AMD. So as we were going through this turnaround, we really set a culture out that was an R&D grounded on really 4 principles. One is transparency. I mean, again, we were the smaller company versus our competitors. We don't have time for any politics or any of that. It's just everyone's got to be really completely candid and open on what's working well and what's not working well. You got to call the ball on what's not working well, and then that moves you into problem solving. You got to call, if you have good transparency, you call out where the problems are and you glom around it. And then third is decision making, being crisp and moving fast at decision making. And then lastly, taking risks. But taking risks in a way, we talked earlier about innovation, managing innovation.
Right.
You got to have the metrics around risk. Are you managing the risk? And if it looks like one of your bets isn't going to make it, did you take corrective action? So everyone thinks it's magical and innovation is and culture change. It just happens. It's actually a very managed process, and one that requires very, very high communication across all levels of technical leadership in the R&D teams and management. Really 2 pieces. One, you have to architect for scale. When we plotted the turnaround, one of the things that we did, again, very, very early on, when we were plotting the new CPU cores and new GPU cores that would take into high performance, we architected a modular approach. Modularity has been so huge to so many industries. And most of us drive an auto every day. I mean, that auto is part of a modular process. How all the piece parts come together has been architected such that you can have any auto manufacturer has multiple lines of autos, yet they have shared components as well to make that car. And we architected that across our chip designs, as part of this turnaround. So we architected for scale, and we created a roadmap that would always have multiple generations in flight. So while one team's working on a given CPU or GPU engine, and they're in the ideation, the innovation phase, another team has already got the previous generation along the development track, and the generation before that is being pushed out into production. So innovation to scale, you really have to architect it, and then you have to implement in a way that's almost like a manufacturing line, where you're in a pipeline process so that you never miss a beat. Our customers, they need that product refresh every cycle. We can't miss a beat here, and we won't. That's our commitment. Well, we are still in the acronym used there. It's called. I'll geek out and tell you the acronym. It's a complementary metal oxide semiconductor, CMOS.
All right, there we go.
So that is how almost any chip you're operating. It's in your phone. It's in your thermostat in the wall. I mean, CMOS is the predominant technology that we have today. But we're getting down to where the thickness of the very transistor that we make, the separation of making a transistor, is actually getting to be only several molecules thick. So you're getting down
Molecules.
to, yeah, molecules. You're getting
Wow.
down to physics. And there is, because I've been in the industry over 35 years, I predate CMOS, and I was there for other semiconductor approach. And every time we hit the end of the road on those other ones, there was the doom and gloom, and it's the end of the semiconductor area, and then there was an innovation. And there's very good innovations in store for semiconductors. So there will be new structures, things like carbon nanotubes and changing the way that the transistor is made and going vertically and stacking, and also what we innovated at AMD is chiplets. So rather than having to grow the size of the chip constantly, we use that modularity I talked about earlier and broke these designs into smaller chiplets. You may not see it because it's under the covers, but when you buy these leading edge Ryzen PCs today, whether it be a desktop, where you go into the cloud and you're operating on an AMD based server, what we actually have is small chiplets connected both horizontally and 3D stacking. For instance, we stack our memory chips on our graphics processors. So we both these new materials for the semiconductor itself, and then new packaging and stacking techniques are very, very promising going forward. So it's different. It's not the old Moore's law. It's a new and exciting way in which we'll be piecing together the functionality using CPUs, GPUs, other acceleration chips that speed the workloads that we all need to get our work done.
And what excites you on the product side? The next generation of these great AMD chips, they're going to be inside, what types of products that excite you? Does it get into the sort of Internet of Things and everything's connected and maybe nanotechnology? But what excites you about kind of what these chips are going to power in the future?
It's what myself and all my colleagues really appreciate at AMD. We get to impact people's lives. And if I just look at the next 2 years, we're launching new high performance PCs and servers. We have our third generation of what we call Epic Server coming out this year. We have our fourth generation of our Ryzen coming out. We work with that same CPU and GPU. We have customized that for Sony and for Microsoft. Each of them have their next generation of game console coming out later this year, and it has the advanced graphics ray tracing, where when you watch an image and the light rays are bouncing around, the math is going on under the covers in the graphics processor that it exactly matches the way that light rays bounce around. So it looks incredibly realistic. And then looking at next year, we have what will be the world's most powerful supercomputer, a 1.5 exaflop, which is 1 billion times 1 billion operations per second, coming out with Department of Energy, Oak Ridge National Lab next year, and then that is used for the world's most difficult problems. So we feel incredibly fortunate to do what we love to do, and that's push technology, but push it in such a way that it's useful. It's helping people solve problems. That's very rewarding for us.